In this algebra basic tutorial, we are going to learn about functions. We will learn how to define a function, define sets, elements, input variables, or otherwise known as domain, and output variables or range of a function, map function tables for different relationships, how to express function table as an ordered pair. Also, we will learn to graph a function and understand the criteria for a rule to be a function, and finally, to test if a graph is that of a function. The literal meaning of function is what something does or what something is used for. Let's think of a microwave. What is the function of a microwave? It is used to heat up food. So when you input food items inside a microwave and set a time, it undergoes a process inside the microwave and we get warm food or drink as the output. So for each item that you input, we get a certain output. Also, you cannot put just about anything inside the microwave to get a desired output for a set time of 2 minutes. See, for example, you cannot put a raw meat for 2 minutes and get cooked meat ready to eat. So it would take much longer time. So also, we cannot put paper or clothes inside. So the items that we can input or we can put inside the microwave for a set time of 2 minutes to get an output ready to eat is called an input set. The set of items you get after the processing is complete is called the output set. So the time set for cooking is the rule that decides what items can be input and what would be the corresponding outputs. Now, how can we relate this to a mathematical function? In mathematics, instead of food, you input numbers. A mathematical function gives you a process for transforming these input numbers into outputs. So in our example of microwave, the processing of a function in the microwave was set by a specific time and was applied to all related food items. So in the same way, the function of a mathematical process is set by a predefined rule in the form of a mathematical operation. So let's look at this example right here. So in this example, let's set a rule to process the input variables in set 1 as output value is double the input value. So let's apply this rule to each value in this input set. Let's see what output we get. So the rule that we define here is output value is double the input value. That means if you input 1, you get double the value of 1 as your output. So that would be 2. So if you input 2, you get double the value of input 2, which would be 4. If you input a value of 3, you get double the value of 3 as your output, which is 6. If you input a value of 4, you get double the value of 4, which would be 8, would be your output. So these set of 2, 4, 6, 8 are called the output values. So you get these 2, 4, 6, 8 when you apply the rule to this input variable. So what is our rule? So our rule is the output values, which is y, which is equal to 2 times the input value. That is 2 times, we put a dot x. Or we can simply say 2x. Before we go further ahead about functions, let's understand a few terms. Those are commonly used in algebra. So we've been talking about input variable set and output value set. So what is a set? So a set is a collection or group of things that share a common attribute. So let's look at these examples. Let's look at the set of alphabets. So can we input a number to this set? No, we cannot. And why? Because the number will not share the common attribute with other elements of this particular set, which are letters. Now let's look at the set of even numbers. So these are 2, 4, 6, 8, 10, 12, etc. till infinity. So can we plug in 11 to this set? We cannot, because 11 is an odd number, and it will not share the same property or same attribute as other elements of this set. So 11 cannot be part of this set. So what about this shapes, set of shapes? Can we input a letter into this set? We cannot, because this set is also defined by a common attribute, which is like sets. So all the elements of this set would be shapes. So we cannot input a letter or a number to this set. Again, set of names. John, Pete, Ria, Tim, Jim. And can you input a date of birth in this set? No, it will be like an odd one out because it doesn't share the common attribute of other elements in this set. So only names are part of this set. So set basically defines the attribute of the elements. The elements share within that set. Sets are, let's define elements. So elements are the items inside a set. In this example, look at the first set. So in the first set, we have A, B, C, D, E, F, G, till Z. So these are the letters of alphabets. And these are the positive even numbers. So this set has all positive even numbers. And this one has all letters of the alphabet. So how do we write the elements? So in mathematical notation, these elements are written within two brackets, two curly brackets like this one right here, and are separated by commas. So what are the elements of this first set? So A, B, C, D, E, F, G, etc. till Z. And what about this one? This one would be all positive even numbers. And it doesn't end at 18, it would go on and on till infinity. The set can have either finite or infinite number of elements. Let's look at the first set, which is set of positive integers less than 10, which has finite number of elements, which has 9 elements, which is finite. Let's look at the second one, set of all positive integers, which has infinite number of elements. So a set can have either finite or infinite number of elements. Now that we have learned what a set is and what the elements of a set are, now to understand how a function relates to sets, we name the set to the left of the function as output set. Input value set, and can be represented by letter X. And the set to the right side of the function are called the output value set, or can be represented by letter Y or as f of x. So f of x simply means the output values are the function of x. That means when you input a value for x, the value that you get is the output value. So that is x. That is f of x. So which would be y, because we represent our output value with the letter y. So a function is something that takes each value from an input set from here and maps it to a value in the output set. That is right here. So these input and output set have special names in math. So this input set, or the input value set x, is called domain, and the output value set y, or f of x, is called the range. So let's look at this example. So let's define the input set or the domain as letters of the alphabet. So that would be A, B, C, etc. till Z. Now we need to apply a rule or relationship to the process to process these elements to get an output. So in this case, let's apply the rule order of alphabets to the processing function. So let's say the processing function or the rule is order of alphabets. That means when you input the letter A to the function, that means when you input letter A to the function, what would be our output? Would be f of A. That would be 1 because it says output value would be the order of alphabet. That means A is the first letter of the alphabet. So we write 1 corresponding to A. And what would be the function of B? When you apply B to the function, f of B would be 2 because B is the second letter of the alphabet. And if you input C to the function, f of C would be 3. And f of D would be 4 because D is the fourth letter of the alphabet. And if you go like that, what would be f of Z would correspond to 26 because Z is the 26th letter of the alphabet. So our range would be 1, 2, 3 up to 26. Now that we know what a set is and what are the elements, what are input variables, what are output variables, or domain and range, and what is a rule, let's define a function. So a function is a relationship between two sets of elements defined by a predetermined rule. It is usually represented as f of x or y. Now in this example, let's look at the input set x, which is 1, 2, 3, 4. So how do we find the values in the output set y? For that, first we need to apply a rule to these input variables. So first we have to define a rule, or there should be a predefined rule. Let's say in this example, let's say that rule is y equals 2x. That means the output value is double the input value. So for each input value, we double that input value, we get the corresponding output value. So let's say in this example, let's say what is the value of the function for x equals 1? So we would call it as f of 1. So f of 1, that means value of the function when x equals 1, which is 2. How did we get that? So wherever you see x, you replace it by 1. So that is 2 times 1, which is 2. Now for the second input variable, which is 2, what is the value of the function when x equals 2? That is f of 2. Again, wherever you see x, you replace it by 2. So we get 2 times 2, which is equal to 4. So that would be our corresponding output value. Now when x equals 3, what is the value of our function? Again, apply 3 to our rule. So wherever you see x, you replace it by 3. So that is 2 times 3, which is equal to 6. So what is the value of the function when x equals 4? So which would be f of 4. That would be wherever you see x, you place it by 4. That is 2 times 4 would be 8. So our input value set will be 1, 2, 3, 4, and your output value set is dependent on the input value. So when you apply the rule to your input values, what you get are the output value. So for each element in the input value, we'll have exactly one element corresponding to that in the output value set. And let's understand this further. These input and output values can be listed in a table form called function table or simply function. So each element in the input variable set of the function table is related to the output set by a rule. So in this example, the input set are the names of polygons. The input set is the names of the polygons. And function could be a rule that says list out the number of sides corresponding to each polygon listed in the input column. So our output value for a triangle would be 3 because triangle has 3 straight sides. If it's a square, it would be 4, rectangle could be 4, pentagon 5, and circle has no straight sides, so it's 0. Now, if you observe this function table, you can see that triangle, square, rectangle, pentagon, and circle has exactly one output value in the output value column. Now, if you repeat triangle, can triangle have 2 number sides? No. That means none of these input variables can have 2 different output values. So triangle can have only one output value. But at the same time, if you look at square, rectangle, and square and rectangle, they both have 4 straight sides. That means one output value can have 2 different input values. That's okay. That's still a relationship, or that still qualifies as a function. So a function relates values of the input set to the output set by a predefined rule. We can also represent a function table as an ordered pair. Let's look at the same example. F of x equals 2x, and our input value set is 1, 2, 3, 4. And if we find the output value set applying the rule to the input values, we get our output value set as 2, 4, 6, and 8. So if we represent it as an ordered pair, so our first ordered pair would be 1, 2, because the x coordinate is the input value for x. And the output value, the corresponding output value would be the y coordinate. So our second ordered pair would be 2, and the corresponding y would be 4. And for the third ordered pair, x would be 3, and the y coordinate would be the output value 6. And for our fourth ordered pair, x coordinate would be 4, and our corresponding y coordinate would be 8. So if we have these ordered pairs, we can also represent this on a graph. Let's plot these ordered pairs on a coordinate plane. So if we plot these points on a coordinate plane, 1, 2 would be right here. Then we have x coordinate 2, and the corresponding y value is 4, which is right here. Then we have 3, and corresponding y value is 6, which is right here. And for 4, corresponding y value is 8, which would be right here. And if we join these points, let's just join these points. Let's see how it's going to look like. So we join these points, our graph is going to look like this. It's a straight line going through our origin. That means 0, 0 means for the input 0, our output is going to be 0. So this is how the graph is going to look like for this function. So we can write this function as f of x equals 2x. So we can represent this function as this graph as f of x equals 2x. If you have to graph more than one function on a coordinate plane, or if you're talking about 2 different functions defined by 2 different rules, these can be represented using different letters other than f. If you see f of x or g of x, like over here, or h of x or k of x, written as a rule or as a function, don't just freak out. It is used to differentiate between different rules or different functions. So when you graph these functions on a coordinate plane, it helps us to identify which graph represents which functions. So if you give the same name for both the functions or both the rules, you'll be confused as to which function, so which graph represents f of x. Is it the first rule or is it the second rule? So if you give two different names like f of x and g of x, people can easily identify which graph belongs to which function or which rule. So let's consider this example right here. So we have function f of x equals 2x. This is our first rule or our first function. And the second one is defined by the rule g of x equals x plus 2. To graph these functions, first we have to write this as an ordered pair, x, y. So our x values are the input variables, and our y values would be, or the y coordinates would be the output variables. So to write this as an ordered pair, first we make a function table. So we have output column and we have the input column and then the output column. So in this first function, f of x equals 2x, let's input values 1, 2, 3, and 4 for x. So what would be our y values? So if you input 1 for the x, our function, the value of our function is going to be f of 1. That means wherever you see x, you plug in 1. So what would be the output value? Would be f of 1 equals 2 times 1, which is 2 right here. When you input value 2 in this function or in this rule, the value of the function would be f of 2. So wherever you see x, you plug in 2. So we have 2 times 2, which would be 4. So our y value would be 4. If you input 3 in this function or in this rule, what would be our y value? Or the value of the function would be f of 3. That means wherever you see x, you plug in 3. So that would be 2 times 3. So that gives us 6. And what would be f of 4? It would be 2 times 4. That would be 8. So if we write this as an ordered pair, we get 1, 2 will be our first ordered pair. And second one would be 2, 4. Third one would be 3, 6. And the fourth one would be 4 and 8. Now let's plot that on our coordinate plane right here. So our first ordered pair is x. When x is 1, what is the value of y? Is 2, which would be right here. When x is 2, what is the value of y? Which is 4, so that goes right there. So when x is 3, what is the value of y? Which is 6, which would be right here. When the value of x is 4, what is the value of y? Which is 8. It goes right up here, right there. So if we join these, or if we connect these dots, we get the graph for this function. So let's do that. Let's connect these. And we get a straight line. Now let's represent the second function on our graph. So for the second function, g of x equals x plus 2, let's input some other values. Let's say -4, -3, -2, and -1. And let's see what would be the value of the function when you input these values in the rule, or these values to our function. So when you input -4, what would be the value of this function? G of negative 4. So wherever you see x, you input the value negative 4. So what would be the value of this function when you input negative 4? So that would be negative 4 plus 2, which is negative 2. Now if you input negative 3 to this function, what would be our value of y, or the value of the function, which would be g of negative 3, which would be wherever you see x, plug in 3. That means negative 3 plus 2, which is negative 1. Same way, if you input negative 2, which would be g of negative 2, and wherever you see x, input negative 2. That would be negative 2 plus 2, which is 0. And when you input negative 1 for x, what is the value of the function? G of negative 1. So wherever you see x in the rule or in the function, input negative 1. So that would be negative 1 plus 2 would be positive 1. So this would be our ordered pair for the second function. So we have negative 4, negative 2, negative 3, negative 1, negative 2, 0, and negative 1 plus 1. And if we plot this on our coordinate plane, it's going to look like this. So we have negative 4 corresponding to negative 2, which is right here. The negative 3 corresponds to negative 1 on the y-axis, right there. And then we have negative 2 in 0. So that goes right there. And negative 1 in positive 1 for y goes right there. So if we connect these, our graph goes like that. So let's connect these. So graph is again a straight line, but goes like that. So that's the best possible way to connect these dots. So now we can name these graphs. So which graph is which one? Now we know. So this is the graph for g of x. So we write that as g of x. So now we know this is the graph of g of x and is defined by the rule g of x equals x plus 2. And this is the graph of f of x, which is defined by the rule f of x equals 2x. So if you write just f of x, we know which rule they're talking about, or we're talking about. And if I write just g of x, we know which rule that we are talking about. This is g of x equals x plus 2. Now that we learned how to define a function, how to find the value of a function for a given input variable, and to graph a function on a coordinate plane, let's ask a question. Can all relationships be a function? Usually, these relationships are written in the form of a rule or as an equation. So can all equations be a function? So before we answer to this question, let's look at this real-life example. So let's consider the relationship between your test scores and grades in your class. So the rule is if you score 90% and above, you get a grade of A. If you score is 80% or above and less than 90%, you get a grade of B. If your score is 70% or above and less than 80%, you get a grade of C. If your score is 60% or above and less than 70%, you get a grade of C. If you score less than 60%, you fail. So here the function f of x, y equals f of x. So here the y, or the output value, is the grade. So this grade is a function of your test score. So if you write the domain for this function, or the input values for this function, it can be from 0 to 100. So one can score from 0 to 100. And your y values, or the output values, would be A, B, C, D, and F. If you score a 0, you get F. If you score 100, you get A. So the conditions are given. Now let's look at three different scenarios. In our first scenario, our score x are 90, 96, 78, 55, and 61. So according to the rule, if you score 90 and above, you get a grade of A. So our y value, or the function of 90, would be A. That is, f of 90 would be A. And if you score 96, what is the value of the function? F of 96. You again get A. You get a grade of A. If you score 78, what is the function? What is the value of the function? That is f of 78, would be C. If you score 55, it would be F. If you score 61, it would be D. So this makes a function. So every relationship is defined, and every input variable does have exactly one output variable. Let's look at the second function table. We have input values 90, then another 90, 78, 55, and 61. In the output values, 90 corresponds to A, and another 90 that corresponds to B, 78 corresponds to C, 55 F, and 61 D. Does this function table look right? It does not. And why? Because in this function table, you can see the value 90, that is the input value, that is the test score, is repeated. And not only that, 90 corresponds to two different y values. So when you input a test score of 90, according to this table, it could have a grade of A. Also, it could have a grade of B, which is wrong, which does not make a relationship, which does not follow the rule. So this relationship is not a function. So this is not a function. Because these two input variables map to two different output variables. So what do we understand from this? So for a relationship to be a function, input values should be unique. Should be unique and cannot, and one input value cannot correspond to two output values. Two output values. So this is not a function table. Now let's look at the third one. Let's look at the third scenario. So here we have input variables, all unique. However, the third one, 78, does not correspond to an output value. So can this be a function? This also cannot be a function. So this is also not a function table because 78 does not have an output value. So according to the rule, every element in the input set should have exactly one output value in the output set. So this one does not satisfy that rule. So this one cannot be a function. So you cannot have one input variable with no corresponding output variable, which also does not satisfy the criteria for a function. Let's look at these two equations. y squared equals x and y equals x squared. Let's find out if these equations is that of a function or not. If you look at the first one, y squared equals x. So how do we find the value of the function? So the value of the function is always y, not y squared. So what is the value of y? We know that y squared equals x. So value of y would be square root of x. So whatever you input for x would give you the value of that function. Let's say, for example, let's input 4 for x. So what would be the value of y? Would be square root of 4. So it could be plus 2 or negative 2. That means for an input value of 4, it can have two output values, which is negative 2 and 2. And does that satisfy the criteria of a function? We have seen in our previous examples that if one input value corresponds to two different output values, that doesn't qualify for a function. Now if we input 9 for x, what would be the value of y? Square root of 9, which could be plus 3 or minus 3. That means if the x values are 9, you can get two different y values, which is negative 3 or positive 3. Again, this doesn't qualify for a function because the same input variable has two different output variables in the output value column. So this is not a function. Now let's look at the second one, y equals x squared. So if we substitute negative 2 for x, what is the value of y? It's 4. So if we plug in positive 2 for x, what is the value of y? 4. So for negative 2, it's 4. Positive 2, it's 4. If we input 3 for x value, what would be the value of y? It would be 9. If we input negative 3, that also would be 9. But this qualifies for a function because every input value has exactly one output value in the output value column. And none of these input values are repeated. And none of these input values correspond to two different output values in this column. So this satisfies the criteria of a function. So this is a function. So y equals x squared is a function. And another thing to remember is that in a function, y is not another variable or unknown quantity. It is the value of the equation when you input a value for x. So y is not a variable. It's not a variable. It is the value of the function. Okay, so y is the value. It's not a variable. So here we only have one variable, which is the input variable. And when you input that variable into the function, what value you get is y, or the output value, not a variable. So y is dependent on x. So what value you get for y is dependent on what value you input for x. Now let's graph the function y equals x squared. So if you input 0 for x, so you get the y value also 0. 0 squared is 0. If you input 1 for x, what would be your y value? That is f of 1 would be 1 squared, which is 1. If you input negative 1 to your function, y equals x squared, you get negative 1 squared, which is also 1. If you input 2, you get 2 squared, that is 4. If you input negative 2, also you get 4. If you input 3, you get 3 squared, which is 9, that is 3 times 3. If you input negative 3, also you get 9. Negative 3 times negative 3, which is 9. So if we plot this coordinates on a coordinate plane, we get a graph like this. We can see, so when 0 is 0. When it is 1, it's positive 1. When it is negative 1, also it's positive 1. This is negative 1. So if it is 2, it's 4 right here. If it is negative 2, also the output value is 4. If it is 3, it is 9 right here. If it is negative 3, also it's 9. So if we join all these points, we get a graph like this. So this is the graph of a quadratic function. Now, to check if the graph is that of a function or not, we can do something called a vertical line test. So in that, we take a ruler and just run through the graph and see at what point it intersects. So here you can see the graph, the ruler intersects the graph exactly at one point all through the graph. Everywhere it intersects only at one point. So this is graph of a function. So let's look at a few more graphs and identify if that is of a function or not. So what we do here is simply do the vertical line test and see if this ruler intersects the graph at just one point or at two different points. And we run this ruler through this graph. It intercepts only at one point everywhere on this graph. If you look at this one, if we run the ruler through this one also intersects exactly one point on everywhere on this graph. And if you look at this one, you can see that the ruler intercepts at two different points almost everywhere on this graph. So this one is not that of a function. So this graph is not a function. Not a function. And this graph is that of a function. And this also is a function graph. Now that you know how to identify by looking at the graph if it's that of a function or not a function. If you find this tutorial helpful, please give us a big thumbs up and hit that subscribe button and turn on the notification so you don't miss another video. Thank you for watching.